Hi friends, in this video we are going to see about a shortcut method of identifying a primary attributes. So let us take an example of identifying a primary attributes. So this is a functional dependency. AB determines CD, C determines B, C determines A. So the basic method of identifying the primary attribute is we want to find a closure property of each and every attribute and a subset combination of each and every attribute. So basically if we want to identify a primary key for this particular problem, first we want to find for A closure, B closure, C closure and D closure, and AB closure and AC closure and AD closure. Likewise BC, BD, likewise CD and ABC, ABD, BCD and finally ABCD. If we got any super key answer, that particular left hand term is called as a candidate key and it is called as a primary attribute. So by reducing the time, third we are going to see a shortcut how we are identifying a primary attribute. So first we want to start with what is the relation given and all the attributes we want to consider. So here it is ABCD. So let us consider ABCD closure. So instead of identifying for individual attribute, let us start all the variable attribute closure. So ABCD closure, for ABCD closure CD, so ABCD is must. So this particular term is super key. So ABCD is super key. Then we are reducing this particular term is consider these four attribute. If it determine anything, reduce that particular term. So for this example ABCD, so D determines B. So for D we can determine by B, or instead of B we can use D. Both are same. Let us see this by later. So for this C will be removed. So now ABC. So for the ABC we want to identify a closure. So for ABC closure, initially the ABC, and whether the ABC determines anything, ABC determines anything, yes, AB determines CD. So already C is available, so D. This is also a super key. Likewise for each and every term we want to reduce the attribute and want to find the closure property. That particular closure must be an super key combination. Okay, so let's reduce from this particular term. So here it is C is removed, hence C tends to A. So C is removed, so instead of that we can replace by A. So AB. So we want to find a closure for this AB. So AB tends to AB. Whether AB determines anything, yes, AB determines CD. So CD. So next we want to this a super key, and hence we want to replace this whether this AB determines any other thing. No, this is the final step, we can't finally determine. So find a closure and B closure. Here A closure determines A and B closure determines B. If this particular key is a candidate key, what we will say means that particular key should be a minimal super key, and for A closure and B closure these both terms should not be a super key of this particular term. Yes, this is not a super key, so hence this AB is called as a candidate key. So first AB, we got one particular candidate key. Next we want to determine whether this AB is available on my functional dependency. We want to check this AB in my functional dependency in my right hand side. Yes, for AB AB is available. For we can replace C, for B we can replace D. So CD can be instead of this B we can replace D, instead of this we can replace C. So this also we want to find a closure. For CD the closure property is CDAB. So the answer is super key, hence this CD is also a candidate key. So first one AB and second candidate key is CD. So we want to check in another combination also, whether this AB and CD is available on my right hand side. Yes, AB is available. So here reduce this AB. So instead of A we can replace by C. So instead of A we can replace by C. So one answer is CB. So find, check the closure of CB. So CB, C closure, B closure. For C closure it is CA and B closure it is B. Hence this key is not a super key. Hence this CB is called as a candidate key. So CB is also called as a candidate key. So this is the third candidate key. And our fourth, whether already we have replaced only C. For B also we can replace. So instead of B we can replace by D. So the another combination is AD. So we want to find a closure property of this A and D. Hence this A and D is not a super key. So AD is a candidate key. Finally the candidate keys are, and we can check whether this both combination is available on the right hand side. Previously we have checked all the combination that is available on my right hand side, so still there is no new terms that is available on my right hand side. So finally we can say, for this particular problem the primary attributes is AB, CD, CB and AD. In next video we will see the shortcut method of identifying a closure property and how we will identify easily the primary attributes and non-primary attributes. In next video let us see. Thank you.